Good morning, students. Today we'll be continuing with Science 1, chapter number 7, Lens. In the previous lecture, we learnt about how to draw the ray diagram related to convex lens as well as concave lens. I hope you practiced it because it's a very important question. Now we'll be continuing with the sign conventions while drawing the diagrams, ray diagrams, as well as while calculating or solving the sums. This question comes in the board exam for a detailed answer, at least for 5 marks. And when you get that question, you have to draw the diagram as well as explain the sign convention. The sign convention in case of a convex lens as well as a concave lens is similar to the geometrical convention, which is called as a Cartesian sign convention. Now here also we consider the optical center as the origin, and the x-axis is similar to or considered as the principal axis. That means the principal axis is similar to the x-axis. Now whenever we are drawing a diagram, we need to remember certain things. The first thing is that the object is always placed on the left of the lens. If you look at the diagram, you can see it's shown positive, negative, that is on the left of the lens. All distances parallel to the principal axis are measured from the optical center. That means when you are measuring on the left hand side, so it will go from O towards left, and when you are drawing for the right hand side, it will go from O to the right hand side. All the distances that are measured to the right of the O are considered to be positive, while all that is measured in the left are taken to be negative. Similarly, every distance that we are measuring above the principal axis is considered to be positive, and all the distance that is we are measuring below the principal axis is considered to be negative. The focal length of a convex lens is positive while that of a concave lens is negative. This is very important. Why? Because when we learned the focal length, we saw that in case of a convex lens, the rays parallel to the principal axis after refraction meets at a point on the other side, that is on the right hand side. That is why the focal length is positive. Whereas in case of a concave lens, what do we see? We say the ray comes from behind the lens. So it is on the left hand side, and that is the reason it is always considered to be negative. This thing you have to remember when you are solving the sums. Because in the exam sums, if it is said that it's a convex lens, you have to remember that okay, the focal length is positive. If it's a concave lens, similarly you have to remember that the focal length is negative. The lens formula. The formula showing the relation between the distance of the object, that is u, and the distance of the image, that is v, and the focal length f is called as the lens formula. The formula is 1 upon v minus 1 upon u is equal to 1 upon f. Now this formula is common for convex lens as well as concave lens. What we have to remember, that is when solving sum, whether f will be positive if it's a convex lens, whether f will be negative if it is a concave lens. Now remember the things, you can say the notations also, that is u is the object distance, v is the image distance, f is the focal length. Don't confuse this with the kinematic equation. There u and v means different things. Magnification. What is the meaning of the word magnification? Magnification means whether the image is bigger than the object. If the image is bigger than the object, then we say that the image is magnified. If the image is smaller than the object, then we say the image is not magnified or diminished. So what is the formula for magnification? M is equal to H2 upon H1. That is, H2 is the height of the image, H1 is the height of the object. The magnification also, there is a formula which is M is equal to V upon U. So we get two formula combining this, that is M is equal to H2 upon H1 is equal to V upon U. We will be seeing when we are solving sum how do we utilize this formula. Power of the lens. The capacity of a lens to converge or diverge incident rays is called as its power. The power of the lens depends upon the focal length. So there is a relationship between the power or the capacity of the lens to converge or diverge as well as the focal length. The unit of power of a lens is called as diopter and it's denoted by capital D. The formula is P is equal to 1 upon F. In the bracket it's written M. What we have to remember is that F is always in meters. So this is the formula that we have to remember. P is equal to 1 upon F. When we talk about a combination of lens, if two lenses with focal length f1 and f2 are kept in contact with each other, the total focal length will be given by 1 upon f plus 1 upon f1 plus 1 upon f2. If the power of the two lenses are p1 and p2, then the effective power of their combination is p is equal to p1 plus p2. This we'll be learning more in detail when we are learning about the defects of the eye. When we talk about how we are using different lenses to correct the defect of the eye. So for now you have to remember the formula. So that means we learned 5 formulas as of now. The first one was the lens formula, second one was magnification, third one was also another magnification formula. Then the fourth one is P is equal to 1 upon F in the bracket M, and the fifth one is P is equal to P1 plus P2.